Okay, here's the spot check answers for the second period APR spot check 15 about building cubic or quintic functions that follow the characteristics of the functions you're given. So these requirements right here to be degree 5 have a double root at x equals 2 and have two imaginary roots. Again, you have to understand that your polynomial you build is going to have the characteristics of the builder functions. So double root at x equals 2, let's see, this is a double root at x equals 2. Okay, you could also use c times d, both of those roots are at 2, but I'm going to use a double root. If you multiply those together, you get a double root. So I'm going to use g, that gives my double root at 2. The only function on here, and this is part of what I'm examining, the only function on here that has imaginary roots is f. So my function is going to be g times f. So that's 2, that's 4, but I need it to be degree 5. I'm going to add on function a to make it degree 5. Now, if you threw in function b or c or d with function g, that would make it a triple root, and we don't want to go there. So if you use g and f, or you could throw in this 0 right here is negative 2. You could throw in b, it'd be a slightly different graph. So let's write out what our function looks like. We're going to have x minus 2 quantity squared times, I'm going to put it in parentheses, x squared plus 2, that is our imaginary, and then times x. This is rather easy to graph because your y-intercept is going to be right there at 0. So the sketch of this is going to look, same thing we've been working on. Plot your zeros. We have a double root at 2, and we have a 0 going through right there. We know this is a 5th degree, and all of these are positive. I didn't put any end behavior on this that had to go down, so this has to be positive up here. Let's see, it's probably going to bounce off there, go through, and here's the double imaginary root right there. There's the two imaginaries, and there's a double root right there, so that adds up to 5.